Hi everyone, so I'll be talking about linear regression, holiday gifts, and trends. So mainly about the Christmas sales and other sales and trends. That's what my linear regression is about. So to start it off, I'll show you like the Christmas sales, just the idea here. So transaction, date, and all that good stuff. Age, gender, location, and then the products they got, categories, and all that good stuff. So that's basically the CSV and the data I'll be using. So to load it, I just do this code, dfpd read CSV. Then I just want to show you the first 5 rows. So you can see here, it prints out the first 5 rows with all the data. And you can see here, mainly, we're going to talk about the events of Black Friday. It could be a not specific event or a Christmas market holiday sale kind of thing. So to make it nice and clean, I use these codes to help me like make the code nicer, especially the ones that are not there. We just put an underscore just to replace it, and also to make it nicer. So we clean the column names. So you can see right here, this is all the categories it all has, and then we just convert the date and time to hours if it exists, and if date is in column, and then we just basically just use the code to convert date into date time. And then if there's a time column, we just convert the hour of the day in numeric form. And then we just filter our December only, but we can do it optionally for Christmas focus, but here we're just going to focus on like it. We're not really going to use like December only, because it could be like other holidays comparison, especially Black Friday and all that good stuff. So we're just going to keep it as it is. So if you look right here, we have the date, age, and all that, and then you can see here for the events, you can see we have Christmas market. This one does not have a specific event, and Black Friday. So honestly, we don't really have to convert it to Christmas, just to show like the holidays. And then to check for the structural data, I just do info for December data and then the summary of the statistics. So you can see right here, it shows the data, the column, the non-null, and the data type for each of the variables that we're using for each of the categories. And then we have like the statistics right here, the mean, the count, min, 25%, 50%, 75%, max, and standard deviation for all of the categories that you see right here. And then we just select the numeric columns only for the correlation heat map. So this is the code that I use for the heat map. And then when I put it all together as a thermal chart, you can see right here, there is some correlation here. So like quantity goes with the total pricing of 0.66, unit price with the total price by 0.67, total price with unit price of 0.67, and also total price to quantity by 0.66. And then you could arguably say discount amount with the total price by 0.37. So the ones that are in orange has a higher correlation. And then the ones in black, darker colors, they don't have a correlation. So you can think of it that way. And then we just put the features that strongly correlate with the data. So target variable price. And then we just have an scalar model for the train test split. And then the linear regression right here with the parameters. So the fit intercept is true, copy x true, total is LE06, and jobs is none, positive, false. And then I'm going to make this chart for the predictions and the actual values and the the perfect line. But here I just did the MAE right here, mean absolute error, MSE and RMSE, which is the mean squared error. So you can see here MAE is 28.17, MSE 14.01.85, RMSE 37.44. Then, like I said before, this is the actual versus predicted pricing. So you can see right here, the one in green is the actual, the predicted is red, and then the gold is the perfect line prediction. So you can see right here, the data for the predicted is not that bad, but it's almost exactly at the line. So not bad at all. And then I just made a featured importance of predicting the total price. So you can see right here, it would be the quantity, then unit price, then the discounted amount. Because many people would buy a lot of stuff, especially, buying a quantity of specific things. So quantity is 54.5, unit price is 2.9, and discount amount is 0.5. And then I made a chart for residuals, actual minus predicted. So I made this chart right here. So we have the frequency and then the residual distribution. So you can see right here, using that purple line that is created right here, you can see that majority is at 0, which means it is not bias. Sorry, not bias, which shows that it's pretty accurate. And that is pretty much I want to show for the holiday gift trends, or you can call it Christmas sales and trends. So yeah, I just thought it was a pretty good idea of doing this data, especially for the end of this year and the Christmas holidays and all that good stuff. So hopefully you learned something about holiday gifts trends and how I used it for linear regression. And hope you all enjoy your Thanksgiving and have a great day, everyone.